Hello, ladies and gentlemen.
Ladies and gentlemen, this is your captain speaking. If you look to the right side of your aircraft, you will notice Flight 198 challenging us to a race.
Welcome back, or welcome if you're new to this channel. It's good to have you here today. In this episode, we'll be looking at how to derive acceleration function and velocity function using the displacement function that we have learned to derive previously for simple harmonic motion, of course without losing our minds. So I'm going to try my best to break it down as simple as possible for you in this video so that you can understand better. So without further ado, let's get started. Now, before going into the topic of this video, I'm going to recap a bit on what we have learned previously because it will be useful in the long run during this video. So first things first, in the very first video, we talked about acceleration equals to negative k over mx, where this shows that acceleration is directly proportional to x, but they'll always be in the opposite direction to each other. That's the first thing we learned. Second thing is we derive equation for the x function, where a cos omega t plus phi. As mentioned before, the presence of phi is not really significant in A-level syllabus because it's not really introduced. So you can ignore this if you're taking A-levels, but if you are studying further physics, as in studying it in higher levels like degree, I believe you might need to take that into consideration. But regardless, I'll talk about both cases for both benefits. Okay, so this is what we have learned in the previous lessons. Now, we know that displacement, velocity and acceleration are related to each other by calculus, right? Whether it's differentiation or integration. For you to get velocity, you need to differentiate. D means differentiate. If I draw the integral symbol means integrate. And to get acceleration, you differentiate velocity. If you want to get from displacement to acceleration, it's also possible. You just have to differentiate twice. Now, going the other way around, you have to integrate respectively. Okay, so today we're not going to look at integration that much. We're going to be focusing on differentiation, most of it. So now, we're going to start with deriving velocity function. So we know that in order to derive the function of velocity, we need to differentiate the x function. So dx dt, I'm going to write here equals to v so that you know that this is a velocity function, equals to, first, we need to use chain rule to differentiate this. This is where you put your differentiation skill into use. So to differentiate x function, the a is there because it's just a constant. Differentiate cos, you will get negative sign. Now, if you're like one of those person like you're not sure whether differentiate cos you get sine or differentiate sine you get negative cos, I'm one of those person, so I found out a way to remember that. So you draw this x first, then you write sine, s is sine, cos, opposite of sine is negative sine, opposite of cos is negative cos. Always opposite to each other is the negative of that. So how does this work? So integrate sine, not integrate, differentiate sine, you go forward, you get cos. Differentiate cos, you get negative sine. Now what if you're going to integrate? So integrate cos, you go backwards. Because differentiate, you go forward, integrate is always the reverse of differentiation, right? So if you want to integrate cos, you go backwards, you'll get sine. You want to integrate sine, you go backwards, you get negative cos. So this is something I found. Best part is I found this in Pinterest. Out of all the places, I found this in Pinterest and it has been really helpful to me. So if you're like me, you're not sure, you sometimes forget on which one you should differentiate and what you should get, this would be really, really helpful. Yeah. I'm just going to put this at the side here. Okay. Now moving on. Okay. So differentiate cos, you're going to get negative sign. Right. Okay. And since we are using chain rule here, we have to differentiate the one in the bracket also. So first we copy this down, omega t plus phi. Now, differentiating the one in bracket, what will you get? So, if you struggle with differentiating constant, I suggest you to use numbers first. That is how I used to do it. So, okay, let me give you an example at the side here. Let's say we have 3 cos
K
7t plus 9. Because omega is a constant, so is phi, and t is just the variable there, right? Okay. So how would you differentiate this? First of all, 3 remains there. Then differentiate cos, you get negative sine. So you get negative sine 7t plus 9. You copy that first. Now, according to chain rule, you have to differentiate the one inside as well. So, differentiate 7t plus 9. What would you get? 9 would be gone. 7t you differentiate, you're just going to get 7. So, it is 7 here. So, eventually, you'll get negative 21 sine 7t plus 9. So, this is exactly the same function as this, just that this has more letters than numbers. So if you always find it hard, like you get confused or you're not sure how to start by writing numbers. When you start doing this, eventually, as in the long run, you don't have to do this anymore. You can actually visualize in your mind how to do this. So for beginning, when you are trying to solve this, you try just for a few seconds, just slowly just draft out the number form. And if you can derive this, use the same method to derive this as well. It works the same way. So now, let's derive this. So, now differentiating the one in the bracket, you're going to just get omega. So rewriting this, you'll actually get negative a omega. I'm going to bring the negative outside to clean up the equation. Sine omega t plus phi. Okay. So now, what if you're not going to use phi? Because in A levels, you don't really need phi, right? You just need a cos omega t. So how does this work? Same way, just that you don't have your phi constant. This is a bit more easier, where it is, you get your a back, differentiate cos, you get negative sine omega t. Remember to copy the omega t. Then don't forget to differentiate the one in the bracket, which is just omega. So you will get negative a omega sine omega t. So it's the same, just that this one has phi and this one doesn't have phi. It's the same way of doing it. Okay. Alright. Well, we've got our velocity function. Now that is our velocity function with phi. Without phi, I'll just write it here as well. We'll just get omega t. Alright. So we have derived our velocity function. Now, moving to the acceleration. So, how do we differentiate velocity to get the acceleration? Because in order to get acceleration, you need to differentiate the velocity, right? Or you can differentiate your x function twice. But now, I'm going to differentiate velocity. So, let's write this as, okay, let's use a different color. Let's see what color you have. Okay. dv dt. I'm going to write this as a equals to, okay. Now we're going to differentiate this function here. So negative a, copy down, constant. Omega also copy, it's a constant. Now, differentiate sine, you get cos. Why? Because you see, let me erase this. Differentiate sine, remember, differentiate, I say go forward. Integrate, you just reverse the position. So differentiate sine, you get cos. Okay, you get cos. So copy back omega t. Now, differentiate omega t, the one in the bracket, you get omega. So rewriting this, you get negative a omega square cos omega t. With phi, you will get negative a omega square cos omega t plus phi. Yep. And this is our acceleration function. So, I want you to notice something. Do you notice that your acceleration function here and your displacement function has some kind of similarity. Okay, now where is that similarity? So if I rewrite my acceleration function as a equals to negative omega square a cos omega t plus phi. Now can you see the similarity? It's this function that is similar, right? Okay. Remember in the first episode we learned this equation? So this is where this equation is going to come in. Okay, I'll rewrite it for you. Okay, our x function was a cos omega t plus phi, right? Okay, and we know that a is equals to negative k over mx. So let's try to compare this equation, okay? Okay, we write the function in this equation back. A is negative omega square a cos omega t plus phi equals to negative k over m. I'm going to put a big bracket here. A cos omega t plus phi. Okay, we have said that this and this are the same. So now when you start to compare this thing, negative omega square is actually negative k over m. Remember we discussed that negative k over m is a constant, right? Now as we compare, we realize negative omega square is equals to negative k over m. That means negative omega square equals to k over m. Negative can be cancelled out. We will get omega square equals to k over m, where omega is square root k over m. So, a better way to write this equation would be a equals to negative omega square x. Now this is the refined version of this equation. You'll use this equation more than this actually. Yep. Now, we have find our omega square, we have already find our constant. Is there something else we can find? Yes. So remember that omega is actually 2 pi over t for one complete cycle, right? So if we substitute this in this equation, we can actually find, not in this particular equation, I mean in this whole equation, we can actually find the period for our simple harmonic motion, right? Okay, so let's proceed to do that. So 2 pi t equals to square root k over m. Okay, I'm going to do this really slow for you to see. So we're going to find our period, right? So let's make our period, the t, as a subject of the equation. So t will be 2 pi divided by square root k over m. Right? So if you do this slowly, you divide, you multiply, right? So your m will go up over cert k. I basically separated the cert so that you can see clearly what we are doing. T equals to 2 pi cert m over cert k, where you can actually combine those two. 2 pi is cert m over k. And this is your equation in finding period for simple harmonic motion. You see how beautiful it is? We started with displacement function, then we slowly go to velocity, we get acceleration function and realize there's something similar. And when we go back to our main equation of this, we see, oh, negative omega square is actually equals to negative k over m. Then, with the knowledge of omega being 2 pi over t, we can find the period of our simple harmonic motion. Interesting, right? It's really nice. Yeah, so that is actually about it on how to derive this equation. Now you might be thinking, how about sine? So sine works the exact same way. It's just that now x equals to a sine omega t plus phi or no phi, anything, is the same thing. You want to get velocity, you differentiate sine, you get cos. So your function would be negative, there's no negative. Differentiate sine is just cos. So it's a cos omega t plus phi. Remember to differentiate the one in the bracket, you get omega. It gives you a cos. Okay, let me rewrite this. A omega cos omega t plus phi. Without phi, you will get a omega cos omega t. The presence of phi actually doesn't really affect your differentiation much. Now, how about acceleration? So acceleration, we have to differentiate our velocity, right? So let's differentiate velocity. So a omega remains. Differentiate cos, you get sine, remember? See here. Differentiate cos, you get negative sine. Sorry, not sine, negative sine. So, wait, okay. Negative sine omega t plus phi. Remember to copy the one in the bracket first, then only differentiate. So you differentiate, you will get omega only. So a is negative omega square sine omega t plus phi, or it's negative a omega square sine omega t only. So actually, to check if you are differentiated right, you see the relation between your x function and your a function. Realize this one is the same as this and this here. So it satisfies the relationship of a equals to negative omega square x. That means you are differentiated. You have differentiated correctly. So yep, that's about it for today's video. Actually, it's mostly differentiation on and how to derive our acceleration velocity function. Well, we've come to the end of the video. That's all for today in this episode 4. We've come really far to episode 4. So I hope this helps you to understand better on how to get acceleration function and velocity just from differentiating our x function. So I will see you in the next video. Bye bye and have a nice day. Take care of yourselves, okay? Bye bye.